So once again here in number 2, we're asked to solve the system by substitution. So our first step is to solve for either x or y. Now, when I look at this, the easiest term to isolate is this y right here because it has no constant in front of it, no coefficient. So I can isolate that y by subtracting 2x from this side. So y equals negative 2x plus 13. So I've isolated what y equals. Y equals negative 2x plus 13. So now in the other equation, 4x minus 3, instead of y, I will substitute in what y equals. From my top equation, we know that y equals negative 2x plus 13. So in this equation, instead of y, I'm substituting in negative 2x plus 13, what y equals. Now I can isolate x in this single variable equation. First, I'm going to distribute this negative 3. 4x plus 6x minus 39 equals 11. So now on my left side, I can combine like terms. 4x plus 6x is 10x minus 39 equals 11. So now I can add 39 to both sides. 39 plus 11 is 50. And then dividing by 10 on both sides, x equals 5. So now that I know what x equals, I need to figure out what y equals. Well, remember, y equals negative 2 times x plus 13. So that's negative 2 times 5 plus 13. Y equals negative 10 plus 13. Y equals 3. So we conclude by saying the point 5, 3 is a solution to the system. So remember, there's still a possibility for infinite solutions and no solutions. So let's just remind ourselves up in the corner, no solution for a linear equation is if your variables cancel out and, for example, you're left with 3 equals 4. That is not true. And remember that infinite solutions occurs when your variables cancel out and you're left with a statement that is always true. So don't forget, we still have these two options as well as finding one point solutions.